Hello everyone, I'm Yifan Chen from Huawei Global Training Center. Welcome back to our Open Source Technology MOOC. This section we are going to discuss open source distributed storage and its selection. Before we discuss the content of this section, let's take a look at our traditional architecture. In this picture, we can see that all data virtualized at the upper layer is stored in the back-end centralized storage system by Sun. If the centralized storage system fails, which is unique single point, then all services can be interrupted at the upper layer, which will directly affect the revenue and the reputation of an enterprise. Traditional mid-range and entry-level storage feature very weak scale-out, incomplete scale-up, and high and unpredictable costs. As a consequence, in the cloud computing era, distributed storage is becoming an extremely popular alternative to traditional storage. With the rapid development of cloud computing, big data, and mobility, the distributed storage that applies to cloud environments enables scale-out and meets user requirements. Distributed storage can be used to store files, pictures, and videos in a secure and reliable way when unstructured data experiences explosive growth. So, what is distributed storage? Let's take a look at the following figure. We can see that the distributed storage is used to integrate disks stored on each server into a storage pool using the distributed storage software and expand storage space for the cloud computing environment and front-end virtualization based on IP or InfiniBand networks. For distributed storage, data is stored on various server disks, and each piece of data is stored with 2 to 3 copies. In terms of security and reliability, the distributed storage is superior to a traditional centralized storage system. Disks on each server are not provided with RAIDs because data is stored on different server disks when using distributed storage. Data switches among servers are connected by 10 gigabit Ethernet or InfiniBand network. Data and services conditions are normal when one or multiple servers fail. In distributed storage, we can consider OSD as a server disk partition and a pool as a storage pool, which consisting of multiple PGs. PG is logical disks that provide storage space for upper-layer service systems. After the user data is written into PG, PG writes the data into active OSD and other OSDs. PG reports to upper-layer server if all OSDs have successfully received the data. Next, we will learn about open-source distributed storage software. It consists of Ceph and GlusterFS. Ceph supports the release of object, block, and file protocols. GlusterFS supports the release of file sharing protocols, including CIFS and NFS. In the figure, we can see that Ceph releases file protocols by CephFS, block protocols by RBD, and object protocols by Rados3W. Ceph releases protocols by APIs based on Librido. That is, users can use APIs of Librido for secondary development or integration with third-party software. Let's have a look at the advantages of Ceph. Ceph provides high-performance storage space and also provides ultra-high-performance storage space if it equipped with SSDs. The Ceph architecture is extremely reliable. If a node fails, services are uninterrupted. In addition, Ceph can meet the requirements about online scale-out of services in the future based on its high scalability. Ceph is widely applied in mainstream virtualization environments such as VMware, Hyper-V, KVM, and ArchHV. Ceph is also very popular in FusionSphere OpenStack private cloud scenarios. It provides professional object storage space for Keystone. Keystone is used for identity authentication, and Swift. Swift is object storage, and block storage space for Nova and Cinder, and file or block storage space for Glance. Next, let's learn about GlusterFS architecture. Like Ceph, GlusterFS is a distributed architecture, and the data exchange among servers is completed on 10 gigabit Ethernet or InfiniBand network. The difference being GlusterFS only releases file protocols. Users can also remotely manage the data stored in the distributed storage space of GlusterFS based on SSH, in addition to accessing the storage space of GlusterFS based on NFS or CIFS. GlusterFS backend stored user data into different GlusterFS shared partitions by global namespace based on CIFS and NFS. Up-layer users can use these shared partitions just like an extra-large storage pool to store data and quickly read their data. The volume of user unstructured data may be up to tens or hundreds of TB, and a large number of files can be generated. In this case, GlusterFS can be used to efficiently replicate data from a local data center to a distributed storage system of a remote data center based on its data replication mechanism that is open to users. Because data cannot be efficiently backed up by backup software. Up to now, we have finished learning about the definition of distributed storage, the comparison between centralized storage and distributed storage, the features and applications of Ceph, and the working principles and functions of GlusterFS. That's all for this course. Thanks for your attending.